last but not least, the Federal Highway Administration is in the process of developing a series of experiments that will be also evaluating the performance of different payment preservation treatments. And to give us an update on the status of these experiments, we have Dr. Gonzalo Rada from APMEC, Foster, and Wheeler. And Gonzalo is a senior principal engineer with that consulting firm. He has served as principal investigator on numerous payment research projects, including 3 ongoing payment preservation studies, one NCHRP project 1433 that deals with payment performance measures that consider the contributions of preservation treatments. There's another NCHRP project 1438 that is a guide for timing of asphalt surface payment preservation, and the study with Federal Highways that is for the design and of the payment preservation experiments for the long-term payment performance program. That is basically the topic of his presentation. So with that, please welcome Gonzalo. Yeah, that works.
Thank you, Luis, and a very good afternoon. Sorry, I'm being too loud. Very good afternoon to all of you. It's a real pleasure for me to be here at this conference to give this presentation on the LTPP payment preservation experiments. Before I get going with the presentation, I would like to acknowledge a couple of key project members who helped put together this presentation. First one is Gary Hicks. I believe most of you know him quite well. Well, I think he's playing hooky this afternoon, so I was hoping he would be here to help out, but obviously not. And then Jack Springer, whom I also believe you know quite well. He is here to help out, so thank you, Jack. I also want to acknowledge and very much thank the members of the expert task group that were set up for this project. They have basically been providing us guidance from the start. They've reviewed and commented on everything that we've produced. A number of the members are here. Ben, Jim Malthrow back there. Am I missing anybody else? Anyways, we've had a really good group of experts helping out along the way. There are 3 topics that I'd like to touch on in this presentation. I don't think that I'll use up the entire time, but first I'd like to sort of give you an overview of our experiment design, the approach that we use, which is a little bit different, especially in comparison with what you had heard from Buzz and from Ben, and I'll explain that shortly. Then we'd like to talk about the deployment of that experiment, basically getting into the construction and the data collection efforts. And then I'd like to end up spending a couple of minutes in terms of the path forward. How do we go? How do we implement physically implement the experiments? Beginning with the experiment design, in the form of background, payment preservation technology has been around for a very long time. It's not a new thing. A big issue has been that much of the decision-making has been based on anecdotal information. So the Federal Highway Administration, and in particular the LTPP program, made a decision that they felt it was important to develop and implement an experiment that would provide the short and the long-term performance data associated with the impact of preservation treatments. By doing so, it would enable verification that preservation is viable technology, which I'm certain that it is, but it would also enable the development of products and tools such as the implementation or the incorporation of preservation in the MAPDG, et cetera, to give an example. In the formulation of the experiment, we start looking at what factors should we consider, and a key factor, obviously, is which preservation treatments to consider. Now, again, you heard from Buzz and from Ben, and you saw a lot of different types of treatments. For the LTPP experiments, we decided to take a little bit different approach, just focus on a few simpler treatments, and I'll expand in that in just a second. In the case of the SPS 11, these are the asphalt preservation treatments. We decided to go with thin overlays, chip seals, and microsurfacing. Why? We happen to be fortunate enough to be working on an NCHRP project where a survey was done, 70% response rate, which was good, and basically these three treatments came up clearly as the most common treatments being used by the state DOT. So that was a very easy thing in the case of the asphalt treatment. Why three? It was sort of a decision that Federal Highway had made that seemed like the right amount of treatments to consider in the experiment given funding considerations. In the case of the SPS 12, this is the concrete experiment. Diamond grinding and joint sealants, again, from that same survey. I think they were ranked number 1 and 3. The third treatment took a little bit more time and a lot of help from Larry Schofield for a number of reasons. A lot of the treatments for concrete are sort of reactive, setting up sections in the hopes that you need to do a partial or full depth patch is not an easy thing to do, especially when we're dealing with 500-foot test sections. So in the end, the decision was made to go with penetrating sealers. It seems to be something that is gaining momentum, especially in the Midwest. Consistent with most other LTPP SPS projects, other key factors included the environment, both moisture and temperature conditions, as well as traffic, which is what I've tried to illustrate here. Unlike most LTPP SPS projects, however, we took a little bit different approach. Rather than setting up a bunch of sections with different preservation treatments, the approach that we decided on, let's just focus on a specific treatment at a given project site. And rather than setting up a bunch of sections where that treatment is applied, let's apply that treatment but do it over time, which is what I tried to illustrate here. So we have a control section, which is very critical for many reasons, but then we apply the treatment at year 0. Year zero means when the project is implemented within the LTPP program. I'm sorry, this is year 0. Then 2 years later, you do the exact same treatment on a different section. 4 years after the project goes into LTPP, another section with the exact same treatment. So in essence, we're applying the same treatment, not at the same time, but at year 0, 2, 4, 6, 8. Those are sort of what we like to do, but that obviously is going to depend on the stress propagation rates. If they're high, we can reduce the timing. If it's slow, we can certainly open up the spacing. But the idea is that we're really focusing on timing on the stress propagation rates, and we feel that that information that would be provided would certainly complement, perhaps supplement, a lot of the work that is being done in studies like ANCAD and MinRoad. So that's a bit of an overview of the experimental design. In terms of deployment, basically the first element is construction of the test sections. And here there is a number of elements that were put in place. A set of nomination guidelines were developed to basically help with the nomination and the acceptance process. Those guidelines contain agency participation requirements, which I'll detail in the next slide. They have selection criteria. I didn't talk about that in the experimental design. Perhaps I should have. But we're really being a little bit narrow on what we're considering. In the case of the asphalt preservation, the only pavement family that we're looking at is asphalt overlays over existing asphalt pavements that are in good condition, that are fairly new, the overlay. In the case of concrete pavements, we're looking at doweled jointed pavements. So those are the sorts of things that we have under the selection criteria. And then, of course, we have nomination forms that the regional support contractors will help the agency complete and move along the entire process. Here's a quick summary of the agency participation requirements. These are basically exactly the same thing that the state DOTs are doing right now in support of the LTPP program. This is basically providing information about the project, when it was constructed, the cross-section, etc. Prepare plan specifications and actually construct the test sections. Signs and markings, help with the material sampling and drilling. The testing would be done by an LTPP lab contractor. Traffic control for performance monitoring, whether distress surveys, deflection testing, etc. And actually provide traffic data. That's probably one of the more difficult ones. And I'll go back to what sort of traffic data we are looking for. And then certainly keep Federal Highway informed as to what sort of maintenance activities or any other activity are affecting the project in question. In terms of construction, we recognize that, and I think this was in a way brought up in the previous presentations, we recognize that in such a study where you're going to be applying the treatments every couple of years, every 1 to 3 years, say, or perhaps even more on the concrete side, that you could have contractors changing, that you could have materials changing. So there could be a lot of things changing. So although not originally envisioned as part of the development of the experiments, one of the things that we decided it was critical to have a good set of guidelines to construct the projects, and also, just as important, just-in-time training, not only for the state DOT and the contractor, as well as the LTPP people involved in the data collection. We felt that this was critical. Now, fortunately, there is a lot of good guidelines out there. A lot of people here have been working on. Jim, I know you have. There's a lot of guidelines out there, and there is a document that contains the recommended guidelines already in place. The only one where we are a little weak and we're trying to improve is the penetrating sealers. And I believe Gary was touching base with Michigan DOT personnel where a lot of this is being done. So anyways, we recognize that there will be variability because of the time nature of the experiment, but we feel that with these guidelines that, and LTPP is very good in documenting just about everything, that we should be, that the negatives are far outweighed by the positives. So those are construction guidelines. Once the projects start being constructed, there's a lot of information that needs to be gathered, and that's basically broken up into these three categories: before construction, during construction, and after construction. Again, these are a set of documents that have been prepared in support of deployment of the experiments. There's a whole set of data sheets that need to be completed, that would be completed by the LTPP regional contractors. But this is important information in order to understand how payment preservation contributes to the performance of the payments, how they perform, why they perform as they do. Something very important too, there's a lot of things that can go into a database, and it will go into the database. But another thing that Federal Highway felt very strongly about is having a construction report for every single project that gets implemented. And basically what you're looking at here is the requirements for those reports. Again, there are guidelines that have been set up for doing this, but these are things that may provide information beyond the data that goes into the database. Things like deviations, which do happen at projects. It's important to have that documented so that the analysts of the data understand what's going on, what happened, why there were deviations, et cetera. Okay, so the test section is constructed as it's being constructed. A very important element in the understanding of the performance of the payments is materials data, the subgrade, the basis, the surfaces, and the preservation treatments. So again, a number of documents, 2 documents to be more specific, have been prepared that address the material sampling and testing requirements. We want to be able to characterize every single layer in the payment structure as well as the preservation treatment itself. So it's not just the preservation treatment, it's going down to the subgrade all the way to the top. In addition, another very important element of this material sampling and testing plan is getting materials to send over to the materials reference lab so that in the future, if new tests are developed, that those materials can be tested and provide the bridge, which is so critical in doing so. I put this slide over here because whenever you hear about LTPP test sections, you always hear about a 500-foot test section, which is this here area in black, and that's really the monitoring portion of the LTPP test sections. The LTPP test sections also include a 50-foot buffer zone where nothing is allowed, and then it also includes 100 material sampling areas. This is where the material is extracted. Payment structure is exactly the same in all of these sub areas. And then there are the transition zones. So the typical LTPP test section is about 1,250 feet, which means the typical payment preservation project, if you need 6 sections, it's going to be about 1.5 miles. And hopefully that 1.5 miles is fairly uniform. There are no traffic entrances, etc. Threw in a couple of slides just in the form of example. These are typical tests that are done on the subgrade soil, sieve analysis, Atterberg, classification, Proctor. We do have resilient modulus, which is perhaps the more expensive one, natural moisture content. So basically the same set of sets that we have for every single layer, for every test section in the LTPP program. Chip seals, even though this is something that is included in the payment preservation experiments, it's something that LTPP has been, it has been applied at many LTPP test sections. So there's a lot of the tests in place, and these are some of the things that are being collected for chip seals. We do require a few new material tests which are not currently part of the LTPP testing, and I've tried to summarize them here. In the case of the asphalt preservation studies, we're looking at the WRI sampling and testing procedure for aging, and this is where I was hoping that Gary Hicks would be to help out on this one, and also the field VA-lit test. In the case of the concrete treatments, some new tests for LTPP will be the mow hardness test, the Texas Transportation Institute camera test. This is basically a camera that is put into the joints on concrete pavements to look at the condition of the joints, what sort of conditions they're in. Also from Texas Transportation Institute, we're looking at a permeability test for when we're looking at the joint sealant experiment to see that does the water flow through the joints or not? Is the joint sealant working? And that's going to be very important in the experiment. And joint damage test, this is something that is being worked on. Again, I wish Gary Hicks was here. It's not quite ready yet. It should be ready soon, and it's something that we hope to incorporate into the protocols. Okay, so now we've got information about the materials, about the pavement. So there are a couple of additional sets of data that we need to characterize, and I'll go through those fairly quickly. Deflection testing, distress surveys, profile and surface texture, these have been done for LTPP test sections since the start. They're nothing new, and we do plan to continue those as part of the pavement preservation experiments. I'll give you some of the details on frequency, protocols, et cetera, in just a second. I've added joint condition surveys. We do joint condition surveys right now as part of the LTPP testing. But I included this one here for the simple reason that we are trying to do a little bit more, whether it's the camera at the joints, whether it's the flow at joint sealants, et cetera. And surface friction surveys will be important for the preservation experiments. LTPP did do surface friction tests for a number of years. The problem was that it was being done by the states, and there were a lot of differences from one state to another, so it sort of stopped. But we're hoping that for the preservation experiments, we can do this on a routine basis. Just a quick summary of the sorts of frequency that we're looking at. Deflection testing every 3 to 5 years, but before accepting a project into LTPP, we would like to do some pre-treatment testing to make sure that the project or the pavements at the project are in relatively good condition. The stress surveys profile, both right before the application of the treatment on an annual basis, et cetera. Protocols we have protocols in place, and if not, they are readily available. In the case of friction surveys, for example, because we are looking at 500-foot test sections, what we're looking is ASTM E2340. This is basically continuous friction survey measurements. So that's what we're hoping for. Plus, we're encouraging the state DOTs to also perform whatever friction testing they typically do within the state. The last set of data that we need to characterize to understand performance and why the performance is as it is includes other data requirements like performance. This is a whole separate document unto itself. We do have the standard elements, traffic. Traffic, we want 3 years of continuous WIM. We feel that that will give really the quality data that is needed. However, unlike shown here with the bending plate, what we're looking for is quartz piezo cables for the WIM system. In terms of climate, unlike other SPS projects, we don't see the need to install weather stations. There are 2 approaches that LTPP is using right now for weather data. One of them is the formulation of virtual weather station based on close by first order and perhaps even second order weather stations. And there's a lot out there. And perhaps even better now, MERA data, satellite data, which has an incredible resolution, and it provides incredible climatic data. And again, LTPP is doing this already. In terms of other data elements, we like what NCAD is doing a whole lot. We feel in the case of the asphalt treatments, one of the reasons why most of the treatments is applied prevent moisture from entering into the subgrade, into the pavement structure. So we feel that subgrade moisture is a requirement. It's something that needs to be looked at. LTPP did use TDRs for many years as part of the LTPP seasonal monitoring program. There are issues, so we are in essence very seriously looking into the ASTM standard with the application of the tubes as being done at NCAD. Snow removal and de-icing data, Ben talked about the importance, especially in areas where you have treatments, snow and ice removal. And then the last thing to point out here, is ground penetrating radar and FWD. We would like to do this before a project goes into the LTPP project. Again, we want to make sure, because it is a time approach, we'd like to be able to get sections that are in fairly good condition that will deteriorate over a period of 8, 10, 15 years so that we can capture that. So it's important that they start in fairly good condition. I have magnetic imaging tool. This is not a mandatory requirement. This is something that would be nice to do. The reason it's not mandatory is that we, again, based on the input from Larry Schofield and others in the concrete area, that dowel alignment is no longer as big an issue as it used to be. So we'd like to have it, but it's not mandatory any longer. This just summarizes some of the frequency and the protocols. So since I'm running out of time quickly, I wanted to get just very quickly to this third and last item, the path forward. We're in the process of finalizing all of the documents, and there is a lot of documents. Just about every slide that I presented, or every 2 slides, is a document. So those are being finalized. They're undergoing final review. They should be ready this year. The next item, and this is something that will be done by Federal Highways, pursuing funding mechanisms. And I'll get back to this on the next slide, but that's going to be important, very important in terms of the implementation of these experiments. Assuming that issue is addressed, then the next logical step, of course, is the recruitment and identification of projects. We're hoping that that will start happening in 2017, the second half, 2018, and then to actually implement and begin monitoring by 2018. In terms of funding, this is incorrect, the first bullet. This is what we had originally talked about, but at this point, and I'll ask Jack to clarify later, Federal Highways is contemplating 2 pool fund studies, one for the asphalt treatments and one for the concrete treatments. So instead of 6 as shown here, two pool funds, and they would be managed by Federal Highway personnel. And with that, I thank you very much.
With that, thank you, Gonzalo, again.
Thank you.
And thank you for your participation.